Hello and welcome to this presentation of our mixed reality teaching course for higher education. The goal of this research is to find a suitable course design to convey mixed reality skills to students. Previous research has already identified the key skills that mixed reality developers need to have. They include knowledge of programming languages, 3D engines, and different AR and VR SDKs. For a deep dive into these tools' functionalities, an understanding of computer graphics is also required. An important qualification for a job in the industry is also the ability to coordinate group work with state-of-the-art practices like agile project management. Moreover, mixed reality also requires different kinds of design qualifications, for example in the realm of 3D modeling. Since there's not yet an established user interface scheme for mixed reality, students also need to acquire qualifications in human-computer interaction, like the ability to quickly prototype and evaluate implementations in order to find intuitive solutions. Since high-end mixed reality requires special hardware like head-mounted displays, knowledge how to handle such devices is also essential. A report shows that students can currently mainly gain the necessary knowledge to become a mixed reality professional indirectly from separate courses. These courses are not tailored towards mixed reality, but instead focus on the particular study program that they are embedded in, for example, computer science. However, there are only few courses dedicated directly to mixed reality that teach all of these skills in one curriculum. Therefore, our goal is to create such a course design that teaches students the key mixed reality skills with a combination of conceptual and practical content. As shown here, the course is divided into two larger phases. In the first phase, students are given a series of tasks which leads them step by step through the creation of a mixed reality application. In the second phase, a larger project is created in an existing open source repository. The first phase follows the scaffolding principle. This means that we give a lot of help in the first couple of tasks, and with each exercise, help is reduced. This way, students can first get acquainted to the tools to build up confidence before focusing on the concepts. All of these created guided exercises follow a core principle that they need to convey. This includes the visual setup of a scene, programming to realize the application's logic, interactions using the immersive hardware, and special placement logic to react to the spatial environment. After that, the second phase consists of a larger group project with 3 reviews. In the first review, students ideate their requirements and user stories according to the agile workflow. After that, they present an initial prototype implementation in the second review, where we give feedback. Finally, the third review contains the full demo of the created solution. In the different instances of the course, we have varied the scaffolding projects. Here's an example where students created a virtual tilt maze. We prepared the 3D model of the maze for students. They were then asked to set up the scene and materials. Moreover, they implemented the pull controls for the joystick in the middle to rotate the maze. A physics-simulated marble then rolls through the maze. In order to proceed, doors need to be opened by a tap gesture, for which students also implemented the necessary code. Students were also guided about adding the spatial mapping ability to the application. With the voice command, the maze can be placed on real objects. All created applications are meant for cross-platform compatibility and work both in AR with a real environment and in VR with a virtual floor. In the second example, the scaffolding project involved implementing a game where apples drop from a tree and have to be collected by the player within a given time limit. It conveys the same qualifications about the visual scene setup, moving virtual objects, interacting with the user interface, physics simulations, and the accurate placement of virtual content on the floor. Apart from these immersive scaffolding projects, we also guided students through different kinds of augmented reality concepts. In one task, students are asked to realize a marker-tracked application for smartphones. Here, they add the necessary Vuforia SDK, place a virtual figurine on a marker, and deploy the solution to a smartphone. After the guided scaffolding phase, the project phase begins. Here, we make use of our open source project ViaProma as a persistent teaching artifact. We developed ViaProma as a mixed reality project management solution with a collaborative virtual space, where developers can organize task cards in the spatial environments. Students work in groups to contribute a new feature to this project. Here are some examples of results that groups produced. In this first example, a group created a visual mockup editor. It allows developers to quickly prototype UI designs directly in ViaProma. This way, the designs can collaboratively be discussed, and the development team can translate them into tasks directly within VIA-Proma. The students therefore incorporated UI elements, implemented their placement, and the persistent storage of the created mockup. In a second example, students added a world in miniature to VIA-Proma. This display maps out the contents of the virtual space on a small platform. This way, users can get an overview and can quickly find the content that they are looking for. The course got positive feedback by students. Nobody dropped out, and they all came up with usable and functioning mixed reality applications. We regard the scaffolding approach as effective, as students start the course without any knowledge about the mixed reality hardware or the common development tools. Despite this, they managed to follow the guided exercises in the beginning, and the number of questions decreased with every lesson. They were able to prove their acquired skills in a group project where we did not need to offer any technical help, and were mainly acting as customers who give feedback about the created implementation.